Konnichiwa. Well, that's the way we say hello in Japan. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics. Now, children, this majestic museum that you get to see is actually the Kyoto Railway Museum, Honshu Islands, Japan. It is here that the Japanese railway history is exhibited through 53 trains spanning from the steam trains to the latest, the Shinkansen trains, which have a whopping speed of 320 km per hour. It is here that you get to meet the official Kyoto Railway Museum mascot, Umitatsu, who tells you about the different technological advancements which have happened in the Japanese railways. Further, don't forget to have the special sweet dish of Kyoto, that is the Kyo Bomb, and also to tell all the people of Japan, Konnichiwa. In this note, children, I'm going to start off this lecture of heights and distances, which initially starts with the two basic concepts of the angle of elevation and the angle of depression. Further, we go ahead to look up a specific case where we also require to make up the figure, and then we go ahead with a proving sum. So let's get started and let's look up this lecture. Further, there is another helpful note for you people, that is, at the end of this lecture, you will get to see in description and also in comments a link which will tell you about heights and distances from a scratch. So if you require to learn more, staying at your home, having a hedge before your examinations, so make sure to click on the link and learn all about heights and distances. So now, children, let's start off this lecture and let's quickly discuss what I have for you people in this lecture about heights and distances. Now, initially, children, when we talk about heights and distances, then we use different lengths which are as heights and distances. We use different angles which have been given in different cases, as the angle of elevation when you're watching something above you, and if there's something which is below you, you talk about the angle of depression when you watch below your height. And as such, we use these angles to use trigonometric ratios linking up the angles and the sides, as you've done in solution of right angle triangles, to find out the different heights and distances which are there in the question. So let's quickly understand how we're going to find out an angle of elevation. So if suppose we have, say, there be a person who be standing at ground level and is watching something above his height, you will be calling in the angle of elevation. For that matter, let's say now we try making a figure for this, and let's say now that there be, say, a boy Rohan who is standing atop, who is standing at the ground level, and let's say there be his friend who is standing atop a building, let's say Qutub Minar, right? And when Rohan watches this friend of his who is, say, John, then the straight line which joins his eye with the object that is Rohan that he is watching, right, will be known as the line of sight. So this line is going to be known as what? It is going to be known as the line of sight. Then next what we do is we draw a straight line from the eyes of Rohan parallel to the horizontal, as he is already standing on horizontal road where his height can be considered to be negligible. So this is something like the horizontal. So if, say, we talk about the angle between both of these straight lines, that is one being the line of sight and the other being a straight line drawn parallel to the horizontal, then the angle formed is known as the angle of elevation, and normally it is depicted by writing a small e in the suffix, right? So I will quickly tell this concept to you again. If suppose there is somebody who is standing and that person is watching something which is above his height, you call in the angle of elevation, right? That means he is elevating his eyesight to watch something. So let's say we have this boy Rohan who is standing here, and he is watching his friend John who is standing on the top of Qutub Minar, right? I'm sure you know that Qutub Minar has a sizable height. So as such, Rohan's height and John's height will be considered to be pretty negligible, right? So the straight line joining the eyes of Rohan with his friend John, which is the object that he is watching, will become the line of sight, right? And a straight line drawn from the eyes of Rohan parallel to the horizontal, if you talk about the angle between both of these, this is known as the angle of elevation, which normally is represented by writing theta, the Greek alphabet, and in the suffix we have e, which represents that this is the angle of elevation. Now, contrary to this, if suppose there be the case where now Rohan is standing on top of Qutub Minar and he's trying to watch his friend John who is at the ground level. So obviously what will happen is we will then talk about a case which is for the angle of depression. So then we will talk about, say here, something like this. We will say that John is standing on top of Qutub Minar, so he is at this position, right? And here then we have John at this position, Rohan at this position, and John at this position, and Rohan is again watching John, right? So a straight line drawn from the eyes of Rohan joining the object that is John that he is watching, right, will be known as again the line of sight. Right, so what is this? This is known as the line of sight. Now further here, if you talk about a straight line drawn from the eyes of Rohan parallel to the horizontal, then it is going to be this straight line, right? And the angle between both of these straight lines is known as the angle of depression, and it is represented by theta, and in the suffix there is a d. Right, so this becomes the angle of depression. So now I'll just quickly discuss this all over so that the angle of depression concept is perfectly clear with you. Now let's say there be a monument, a tower, on top of which a person is standing, and let's say the person is watching something below his height, then you will be calling in the angle of depression. Now what do? You first talk about a straight line which is the join of the eyes of the person who is standing on top. In this case we have Rohan who is watching John who is standing at the ground level, say, and he is standing on top of Qutub Minar. That means it's a body which has quite a lot of height. As such, Rohan's height and John's height are going to be considered to be negligible. As such, they will be considered just as points. Now, a straight line joining the eyes of Rohan to the object that is John that he is watching will be said to be the line of sight, right? And another straight line drawn from the eyes of Rohan parallel to the horizontal, if you talk about the angle between both of these lines, you will say that that is the angle of depression, right? And it is represented by theta, and in the suffix you have d, right? So this, children, is the concept of the angle of elevation and the angle of depression, right? After you have understood this concept, I'm sure you will try to crack the sum that I have for you people next, right? And that is this. So now, children, I'll give you people, say, some 10 seconds for trial, after which I will be discussing the sum with you people. If you want more time, then you can pause the lecture and give it a further valiant try. I'll be more happy if you take some good time to try out the sum all on your own before I discuss the sum. And I can assure you, you'll be feeling very happy if you can do the sum before I discuss it. Okay, now let's discuss the sum, children, thinking that you've given it a valiant try. Now the question says, if the angle of elevation of a cloud from a point h meter above a lake is beta, right, and the angle of depression of its reflection in the lake is alpha, prove that the height of the cloud is so much. So first what we require to do is, first we require to make a point which is at some height, right, above the lake surface. So let's say now that we have that point to be, say, something like this, and let's say this be a point which is above the lake surface. So where is the lake surface? Now we're going to make the lake surface something like this. So this is the lake surface, right? And h meters above the lake surface we have this point, right? Now from this point, a cloud which is above the point of observation is being watched. So next what we do is we are now going to make a line which will be the line of sight joining the eyes of the observer to the cloud that he is watching. So let's say the cloud be at the end of this line, and this line be the line joining the eyes of the observer with the cloud, right? Now children, here we are talking about the reflection of the cloud. So if say we talk about the reflection of the cloud, you require to remember that the water of the lake will just act like a plane mirror. So remember, in a plane mirror, when you're standing in front of it before you get dressed up, right? I'm sure you get dressed up so well that you tend to look that you are probably the most attractive person, and that's why quite a lot of time of young people is spent in front of the mirror. Now one thing you people must have noticed is as much amount of distance you have before the plane mirror, the same amount of distance your image has from the plane mirror, right? So that is why you try to stand close to the plane mirror so that you can have a good look, because if you tend to stand far away, then there are many things which you're not able to look, which have yet to be made to be proper, right? So as such, you got to remember one thing: as much as is the distance of the object before the plane mirror, same is the distance of the image after the plane mirror or behind the plane mirror, right? The same thing we are going to have here when we talk about the image of the cloud in the lake. So as much as its distance is above the lake, the same amount of distance will be that of the image of the cloud in the lake or underneath the lake, right? So this concept is what we are going to use. But first children, as we've been given that the angle of elevation of the cloud is beta, so first we're going to mark it. So now we already have drawn the line of sight. We've now got to draw a straight line from the eyes of the observer parallel to the horizontal, right? So now next we draw this straight line, which is the straight line joining the eyes of the observer parallel to the horizontal. Now the angle between both of these is going to be said to be the angle of elevation. So here we have this to be the angle of elevation, and as has been given in the question, this angle has to be marked to be beta. Now next what we are going to do is we will now be joining this point, the cloud, right to the lake, because now we require its reflection. So let's say this be the straight line which is the join of the cloud to the lake. Now obviously this same amount of distance is to be produced underneath the lake so as to get the reflection of the lake. So next now we'll be making this straight line further, right, which will show its reflection underneath the lake. And remember, this distance is to be equal distance, right? So this is that straight line which represents the distance of the image underneath the lake, right? So here children, we've been given that the height of the point of observation is h. As such, here we can mark this distance also to be h, right? So both of these distances are h, as these two lines are parallel, right? And except that they are between two parallel lines also, this angle being 90, right, and this angle also being 90, as here we have the point of observation which obviously is going to be vertical, right? And when we are drawing a straight line, obviously we'll be drawing a straight line which is normal to the lake surface, right? Further now children, if we assume that the distance of the cloud above the point of observation is say some h, right, then we can mark this distance to be say some h. Okay, so the earlier distance is h, so we will mark this distance to be say some y, right? So we have this distance to be y. As such, y plus h will become the height of the cloud above the lake, which is what has to be found out in the question. Now, as the height of the cloud above the lake is how much? Is y plus h As such, the same distance y plus h is going to be this distance. That is the distance it has underneath the lake surface, right? So as such, now we're going to make the image of the lake. Now, as the image of the lake is also being observed from the same point of observation, so now we're going to join this to the point of observation by means of a straight line, and that, children, is going to become your line of sight, right? So a straight line joining the eyes of the observer with the object that he is watching becomes your line of sight. So this is that straight line. Now the angle which it has with another straight line which has been drawn from the eyes of the observer parallel to the horizontal, right, is this straight line, right? So the angle between both of these straight lines will become your angle of depression. So in this case, we can mark this angle to be the angle of depression, which has been given to you to be alpha, right? Remember that this is a straight line parallel to the horizontal, and if you talk about this straight line in itself is the horizontal, right? Now after this, children, we are going to mark the strategic points, which are the points which are required in the figure. Let's say we talk about the point where the cloud is A, the point where we have the point of observation to be B, next point to be C, then we have D, then we have this point as E, and further we can mark this point to be, say, some F, right? So these are all the strategic points which in times to come we will require in the figure. So let's first quickly have a look about the question, and looking up the figure, let's quickly check whether all that has been there given in the question is all there in the figure, and for that matter you will also be able to understand how to construct the figure also. In the question here, you've been given if the angle of elevation of a cloud from a point h meter above a lake is beta. So here, children, this is the lake surface. This is a point which is h meters above the lake surface. From here, a cloud is being watched, right? And the angle of elevation that it has is beta. So a straight line joining the eyes of the observer to the object that he is watching, that is the cloud, becomes a line of sight, and its angle with another straight line drawn from the eyes of the observer parallel to the horizontal will become the angle of elevation. Now further, we talk about the image of this cloud. So as much as is the distance of the cloud above the lake, same amount of distance if you produce below, you will get the image of the lake. So as this distance is h plus y, so obviously this distance also is going to become equal to h plus y, right? Now, children, what you've got to calculate is you've got to calculate the height of the cloud above the lake, that is h plus y, right? And now here we've also been given here that the angle of depression of the reflection in the lake from this point of observation is alpha. As such, if you join the eyes of the observer with the object that is the image of the cloud, then that will become your line of sight, and this is a straight line which is the join of the eyes of the observer parallel to the horizontal. The angle between both of these will become the angle of depression, right? Now when you further talk about this angle of depression, we have now a right angle triangle that is BFE which has been produced, and then you have another right angle triangle which is ABF, right? Now in both of these right angle triangles, we'll be talking about the heights and distances, and then we will try and prove the height of the cloud above the lake to be this, right? Now remember, children, here we have this angle which is AFB to be 90, and similarly we have this angle in triangle BFE to be 90. So first triangle, first we'll be talking about the triangle ABF, right? So now we say in triangle ABF we have what? We have to use the side which is in front of the known angle, that is the perpendicular. We have to use the side which is the third side, that is the base, right? And we don't have to use the hypotenuse, which is the side in front of 90. As such, we will be now talking about tan beta to be equal to perpendicular upon base. As such, here we can talk about this distance which is AF to be the perpendicular, right? And we can talk about this distance, which is BF, to be the base, right? And as such, we can now talk about tan of this angle beta to be equal to perpendicular upon base, right? Which here is equal to how much? It is equal to AF, which is to be divided by BF, right? Now here, children, we can keep the value of these distances. That is, we have tan beta, which is then going to become equal to the distance AF, which we have assumed to be y, to be divided by BF. That is the distance which you can assume to be, say, some x, right? As such, here we have tan beta to be equal to y upon x, and now, children, this becomes the first equation, which in times to come we are going to use. Now we talk about the other right angle triangle. That is, we talk about the triangle BFE. In this triangle, children, what we have is, we can talk about tan of angle alpha to be again equal to perpendicular upon base, as tan of an angle always is. Now, children, remember, the side which is in front of this angle alpha will become your perpendicular, that is this side, which is FE, and the side which is in front of 90 will be your hypotenuse, which you're not going to use, and the third side will become the base, right? So again, now writing in a different color so that you can understand, we have the base of this triangle BFE to be BF, right? And further, if you talk about the perpendicular, that is FE, that is this side, so this becomes your perpendicular, right? And now we're going to keep the values of the perpendicular and the base. So the perpendicular is FE, so further this is going to become equal to FE, which will be divided by the base, that is BF. Now, children, in this we substitute the values. That is, we now talk about tan alpha, which becomes equal to FE, which is here, as you can see, F and E. That is, it is H plus Y plus H, right? So here we will have H plus Y plus H, which is going to be divided by BF, which is the base whose length is X by assumption. So here further we will now have tan of angle alpha, which is going to become equal to 2H plus Y divided by X, right? And this, children, is going to become the second equation. Now we have two equations here, and as you can see, we have two unknowns here, right? One is Y and the other is X. One is Y and the other is X, right? And if you see in what we have to prove, we don't have to bring in this X and Y. As such, our task is first to find out the value of X and Y in terms of alpha, beta and H, right? So this we can do by first keeping the value of Y to be X tan beta in the second equation. So this is what we are going to now do. That is, we will keep the value of Y to be equal to X tan beta, and here we can write, we are doing this from equation number 1, right? So from equation number 1, what have we got? We have got Y, which can be written to be equal to X tan beta, and this is the value that we've kept here, right? So this now is going to be substituted in the second equation. Now when we talk about the second equation and bring in the second equation, we will keep this value of Y. As such, we will now have tan alpha, which will become equal to 2H plus this value of Y that we found out, that is X tan beta, right? And it is going to be divided by X. Now as you can see, there is just one unknown, that is X, and now we're going to make it the subject of the equation to calculate its value in terms of H, alpha and beta. So further cross multiplying, we have X times of tan alpha, which becomes equal to 2H plus X times of tan beta, and further then we have X tan alpha minus X tan beta, which becomes equal to 2H. So all the terms with X are on one side. Now our task is to make X the subject of the equation. As such, we will take X to be common outside. We have X times of tan alpha minus tan beta, which becomes equal to 2h, and further x will thus become equal to 2h, which is going to be divided by tan alpha minus tan beta, right? Now after this, children, as we have the value of x now, we are going to substitute this value in equation number 1 to get the value of y, right? So further we will write the statement substituting x in equation number 1, right? And when we do so, we have the value of y to be equal to x tan beta, remember? So in that we will substitute, which is actually equation number 1. So here thus we have y, which is equal to x tan beta, right? So we keep this value of x that we've just found out, that is 2h upon tan alpha minus tan beta, right? And further we multiply that with tan beta, right? So next now, children, after that what we do is we have here 2h tan beta by multiplication, right? And in the denominator we have tan of alpha minus tan beta, right? Now children, remember what we've got to find out. We've got to find out the height of the cloud, right? Find the height of the cloud. So height of the cloud above the lake obviously is to be found out, and as this is the lake surface, I will also write it so that you can make no mistake. So this is the lake surface and this is the height of the cloud above the lake. So it's going to be equal to y plus h. We have the value of y now, so we've just got to add h to it. So next now we're going to write this height of cloud and it will become equal to, here further, h plus y. Now h to that y is going to be added, which we've just calculated to be 2h tan beta divided by tan alpha minus tan beta, right? So for the children, if we calculate this, this is going to become equal to h times of tan alpha minus tan beta, right, plus 2h tan beta, right, divided by tan of alpha minus tan of beta, right? Now for the children, here we have some simplification which we can do, that is we have h tan alpha minus h tan beta plus 2h tan beta, right, which is now going to be divided by tan alpha minus tan beta. Further here we have h tan alpha, which is going to be left, and except that we have minus h tan beta and 2h tan beta, which are like terms. As such, we'll be left out with h tan beta divided by tan alpha minus tan beta. Now in the numerator, children, we can take h to be common outside. As such, we will then have h here taken common outside, and inside we'll be left out with tan alpha plus tan beta, and in the denominator we have tan alpha minus tan beta, and this is what we've got to quickly check whether it's matched or not. So we require here in the numerator h times of tan alpha plus tan beta, so we have h times of tan alpha plus tan beta, and in the denominator we should be having tan alpha minus tan beta, and it has matched, and therefore we can say that the sum stands proved. So I'll just quickly discuss the sum all over so that if there is any ambiguity anywhere, all of that gets cleared. In the question, children, we've been given here that if the angle of elevation of a cloud from a point h meter above a lake is beta, so we have first drawn a figure which shows this to be the lake surface, this to be the water within the lake. Now above the lake there is a point which is h meter high at B, say, from which a cloud which is at point A, say, is being watched. So this straight line joining the eyes of the observer with the object that he is watching becomes the line of sight, and further the angle which this straight line has, with another straight line drawn from the eyes of the observer parallel to the horizontal, becomes the angle of elevation. And here it's been asked that it is beta, so we mark it to be beta. Now here, children, remember that if we talk about this right angle triangle, then the side which is in front of this angle beta will become your perpendicular, the side which is in front of 90 will become the hypotenuse, and the third side will become the base. As we have this length which is going to be used in times to come, and we require to use this right in both the triangles, as such here we will be talking about such a trigonometric ratio which uses the perpendicular and the base, and that, children, is tan. As such, we have tan beta to be equal to the perpendicular divided by the base, that is y by x, right? And that thus is the first equation. Now we move ahead. We've been given that the reflection of the cloud in the lake is also being observed from this point B. So next, now we talk about the reflection. As much as is the distance of the cloud above the lake surface will act like a plane mirror. So the same amount of distance, if you go below, you will be able to get to the image of the lake, right? So as such here, what we do is we now talk about the reflection of the lake. So the distance of the lake above the lake surface is y plus h. And now if we talk about the distance which is below the lake surface, it should also be y plus h, right? So y plus h is the distance above the lake, and y plus h will be the distance of the image below the lake, the same amount of distance. Now, joining the eyes of the observer who is standing at B to the object that he is watching, that is the image of the cloud which is at point E, this becomes the line of sight, right? And further, another straight line drawn from the eyes of the observer parallel to the horizontal, which is this, that is the lake surface, becomes this. Now the angle between both of these straight line becomes the angle of depression, which here is alpha, right? Now you talk about the right angle triangle, which is BFE, and in that the side which is in front of this known angle alpha becomes the perpendicular, which has been marked here. So the perpendicular becomes equal to h plus y plus h, right? And the base still is the assumed value x. So we have tan alpha, which becomes equal to perpendicular upon base, which is FE divided by BF, right? And its value, just as we looked up, is h plus y plus h divided by x. Now further, that becomes equal to 2h plus y divided by x. Now here, children, in these two equations we have two unknowns, that is y and x, whose values we've got to calculate, because in what we've got to prove, that is the height of the cloud above the lake, there is no x and y. So now what we do is we talk about both of these equations that we have, equation number 1 and 2, and we now next try to calculate the values of the unknowns x and y. So first what we can do is we use the simpler equation. We can write the value of y as x tan beta in the second equation. So y is equal to x tan beta from equation number 1 is going to be substituted to the second equation, that is in place of y. Now we write this x tan beta, right? And then we cross multiply x to the left hand side. We have x tan alpha. We take the term x tan beta to the left hand side so that we can have all the terms with x on one side, and then taking x to be outside, we have tan alpha minus tan beta inside. And then next what we do is, as x here has been taken common outside, next now we transpose tan alpha minus tan beta to the denominator of 2h on the other side. As such, we get the value of x. Now substituting this value of x in the first equation, where we got y to be equal to x tan beta, right, can be substituted. So we have y is equal to x tan beta. We keep this value of x that we've just calculated, that is 2h upon tan alpha minus tan beta multiplied by tan beta. So it becomes equal to 2h tan beta divided by tan alpha minus tan beta, which is the value of y. Now as we've got to calculate the value of the cloud, right, the height of the cloud above the lake, so that here is h plus y. So to this value of y that we've calculated, we've just got to add h to it. So we add h to it. So h plus this value of y, right, that is 2h tan beta upon tan alpha minus beta, right, is going to be the value which is going to be added. Now we take an LCM, so that will become h tan alpha minus h tan beta plus 2h tan beta, right? So further here, children, we have h tan alpha minus h tan beta plus 2h tan beta. Now h tan beta and 2h tan beta are like terms, so we have out of this one term getting cancelled and we are just left out with h tan beta. Now out of the first two terms in the numerator, we have h common, we can take it outside. Inside we are left out with h times of tan alpha plus tan beta divided by tan alpha minus tan beta, and it is what exactly matches with what we had to prove, and therefore the sum stands proved. So are you all clear about this? For sure? That's good, children. Now remember, children, after you understood the sum, I expect you people to try out the whole sum, right, once before doing so. Make sure that you've understood everything. If you haven't understood in one go, look up this once more. Then do practice this once or twice so as to make this for sure perfect, so that if this comes in your examination, you are able to do this for sure and get full marks. And like I told you, if you want to learn this topic from a scratch, what you can do is you can click on the link, right, which is in the comments or probably in the about the video, that is the description of the video. In both the places you will find the link which you can click, and then you can get the whole lecture series of heights and distances, right, and then make yourself perfect, staying at home at your comfortable place and getting an edge in this topic, right. And if such sort of sums come in your examinations, right, in the lecture series, I can vouch that all the different type of sums are there. If you practice it, then for sure any sum comes your way in heights and distances, you'll very easily be able to tackle it, right? So bye for now, have a nice time, make sure that you perfect heights and distances and get great marks. Bye guys, have a nice time, bye.